Hello and welcome to another video recording for another topic in Additional Maths Year 9, Chapter 7, Equation, Inequalities and Graphs. So today we're going to deal with solving cubic inequalities graphically. So here, cubic equation, okay, as you can see here on the left side, will be given in this factorized form. Now what will happen here is that the inequality will be either less than or equals to or more than or equals to. Sometimes it can be less than only or it could be more than only. And then there's a constant here d. So this one, it kind of relates to the previous topics on quadratic inequality. So here, the first thing that you have to notice that the inequality can be separated into two equations with subject y. So if you're given a graph of a cubic equation over here, the graph of cubic is going to be this one, but another number on the right side will be another equation, so that one will be a straight line. Okay, so that line will be this one. Draw the line y equals to d on the same axis as the curve y equals to k bracket x minus a bracket x minus b and bracket x minus c. So with that, later with that line, you will identify the region where the solution satisfies the inequality. So let's have a look at one example. So over here, we will use graphical method to solve this. Now, in this diagram, it shows part of the graph of y equals to 1 over 6 bracket x minus 3 bracket x minus 2 bracket x plus 2. So use this graph to solve this inequality. So at first, if you can see, you compare between these two, they are actually quite similar, but compared to the original equation of the graph, which is this one is 1 over 6. So if you want to compare this, to use this question, so here you must multiply the whole thing by 1 over 6. So you have to do some sort of like modification in order to use the graph. So here, what you will have is 1 over 6 will be multiplied on the left side. So the rest of them will be this one. X minus 3 bracket x minus 2 bracket x plus 2. The inequality over here is going to be less than or equals to, and the number 6 will be multiplied with 1 over 6, which will give you 1. So here, as you can see from the last steps to success, you will draw the line y equals to d. So in this case, your line is y equals to 1. Okay, because this one, if you can see, the graph itself is this one on the left side of the inequality. So the line that you will draw is y equals to 1. So let's draw y equals to 1. So it is going to be a horizontal line. Okay, a horizontal line that will pass through 1 on the y-axis. So this is y equals to 1. Okay, now let's figure out the solution. So based on inequality, it is less than or equals to. So based on this inequality, it is like saying that what is the solution such that the graph of the cubic equation is below y equals to 1. So over here, if you can see, based on this inequality, less than or equals to 1, it is the part of the graph that is below y equals to 1, the cubic graph, I mean. So this is this part and also this part. Right? So what is the solution? Meaning what is the value of x? Okay, what is the value of x? So for the first one over here, okay, we are estimating. So this one will be about negative 1.2, 1.4, 1.6, 1.8, negative 2. So this is x equals to negative 1.8. Okay, so for the first one over here, this is the region where the graph of cubic equation is below y equals to 1. So this one, it looks like the first solution is going to be x is less than or equals to negative 1.8. So that's the first solution for the first one. So here, this is the part of the cubic graph where it is below 1. Okay, the next one over here is this part of the graph. So this part of the graph is defined between x equals to 1 and estimation over here. This is x equals to 3. Okay, let's count it out. 3.1, 3.2, 3.4, and 3.6. So this is 3.6. So based on this graph, so how are you going to define the solution is therefore it is between. So you are going to use 1 is less than or equals to x and is less than or equals to 3.6. Right? So this is the solution for this part of the graph. Okay? Alright. Now, let's move on to the next example. Next example is over here. Okay, the diagram shows part of the graph of y equals to 1 minus x, bracket x minus 2, bracket x plus 1. Now use this graph to solve each of the following inequalities. So for part A over here, 1 minus x, bracket x minus 2, bracket x plus 1 is less than or equals to negative 3. So here, based on part A on the left side, this is your graph, okay, cubic graph. But the second one is y equals to negative 3 on the right side. So here you are going to draw the line of y equals to negative 3. So y equals to negative 3 is a horizontal line that will pass through y equals to negative 3 over here. So it is concerning a part of the graph, cubic graph, where it is below y equals to negative 3. So based on the graph over here, it is this part. So the region that you're looking for is over here, right? So this region can be defined as, okay, let's have a look at this point, the intersection point. Estimation over here, it would be about this x value. So in this part, x equals to 2.2, 2.4, this is 2.6. Okay, this is 2.6. So estimation is for part A, the solution is going to be x is more than or equals to 2.6. Okay, depends on what you have on your graph over here. So this is for part A. All right, moving on to the next part, let's move to part B. So part B, it's the same graph of cubic, but this time the inequality on the right side is going to be a 0. So y equals to 0. So this is the graph, or the cubic graph, that is already on the diagram. And you are figuring out y equals to 0. So y equals to 0 is on the x-axis. Horizontal line along the x-axis, this is y equals to 0. So in this case, it is looking for the solution where the cubic graph part is below, okay, because this is less than, so it is below y equals to 0. So in this case, the part of the graph, a cubic graph that is below y equals to 0 is this one, and also this one. Alright, so there are two regions. So the first one is going to be this one. So in this one, it is quite obvious that the region where the cubic graph is below y equals to 0 is situated at x between negative 1 and also positive 1. So the first solution is this one. Okay, so the x is from negative 1 to positive 1. So that's the first solution. And then as for the second one, the region of the graph, the cubic graph that is below y equals to 0 is this one. So this one, it is starting from x equals to 2 and it is going to the right side. So this the second solution is going to be x is more than or equals to positive 2. Alright, so that's for part B. And let's have a look at the last part for this example, which is part C. So it is saying that the x or 1 minus x, bracket x minus 2, bracket x plus 1, this is the cubic graph, is above y equals to negative 1. Okay, the inequality over here is more than. So let's figure out where is y equals to negative 1 first. So y equals to negative 1 is over here, right? Over here, the horizontal line where it passes through y equals to negative 1. So the part of the graph that is above y equals to negative 1 is going to be here, this part of the graph, and also this one. There are two regions or two inequalities that you have to figure out. So for the first one, this is going to start from x equals to a number over here. So this number is negative 0.8. Negative 0.8. So the first region, therefore, is going to be x-is. Okay, this is going from negative 0.8 going to the left. So this is less than or equals to negative 0.8. Right? And as for the second solution, the x is over here and here, the intersection point. So this one estimated is going to be 0.2, 0.4, 0.6. So this is x is 0.6, and also this one. So this one, if we're using estimation over here, this is about 2.2. So the last one is going to be between 0.6 and 2.2. So the inequality is going to be 0.6 less than equals to x less than 2.2. So this is the definition of the inequality for both solution. This solution defines the value of x where the graph, okay, the cubic graph is above y equals to negative 1. Alright, so let's have a look at the last example. Over here, okay, over here you have a past year paper question. Okay, the diagram shows the graph of y equals to fx, where fx equals to a bracket x plus b squared bracket x plus c, and a, b, c are integers. Okay, so part A, find the value of each a, b, and c, and then hence solve the inequality fx, which is the cubic graph, is less than or equals to negative 1. So this is kind of related to our previous lesson on how to make the equation of a cubic graph. So over here, if we have a look at the graph itself, there is a part of the graph that is only touches x equals to negative 1, okay, at one point over here, at only x equals to negative 1, and at x-axis also there is x equals to 1. Alright, so x equals to 1 over here, and on the y-axis it touches a point where y equals to negative 2. Okay, so here let's have a look. Okay, for this one, for obviously this is repeated root as we have seen last time. So this one is reserved for a part of the graph that touches only at one point. So in this case, this is your B. So for this one, since for part A, since x minus 1 is repeated, okay, so which will make x plus b is negative 1. So b, okay, b is going to be plus 1. This is x plus 1. So therefore b equals to positive 1. Right? And x plus c is going to be another root. So this one. So x equals to 1. So if x equals to 1, then you move the 1 to the right side. So this is going to be x minus 1. So therefore, c is going to be a value of 1. Right? So far for fx, we have a bracket x plus 1 squared, and then c is, sorry about this one, c is a negative 1. So c is negative 1, so x minus 1 is on the next one. So here, let's have a look on how to find a. So for a, we have to depend on the value where the graph touches the y-axis at y equals to negative 2. So at y-axis, so if y equals to negative 2, in that part, x equals to 0. Okay, so this coordinate is a 0, negative 2. So you are going to substitute this into the fx above so that you can find the value of a. So y equals to negative 2, this is also fx. Okay, fx equals to negative 2. So the negative 2 equals to a, and then x plus 1 is 0 plus 1. So a plus 1 times 1 square times 0 minus 1 is negative 1. So here, the negative 2 equals to a, the coefficient of a is 1 times negative 1 is going to be negative 1a. So there we have it. Therefore, a equals to 2. So your complete fx, okay, fx equals to, okay, this a equals to 2 already, x plus 1 square, x minus 1 square. X minus 1, there's no square, okay. Sorry about that. So that's for part A. So A is 2, okay. B is 1, and C is negative 1. Okay. The next part is, hence solve the inequality fx, which is your cubic graph, is less than or equals to negative 1. So here, like previous example, you have to figure out where is y equals to negative 1. So in this case, y equals to negative 1 should pass through y-axis where y equals to negative 1. So based on the inequality, you want to solve x where the graph, the cubic graph, is below y equals to negative 1. So this is the region that you have to look for. This one, and also this one. Okay, as you learned previously, okay, in the previous example. So in this case, you have to find two solutions. So let's estimate the value for the first one. The first one over here, it's going to be, okay, estimate this one. Okay, it is between 2 points, okay, for this one. So this one, if we read through the points in your graph, negative 1, then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each value on the small box is going to be 0.1. So this is negative 1.1, negative 1.2, negative 1.3, negative 1.4, and negative 1.5. So between negative 1.4 and negative 1.5, it's going to be negative 1, 2, 3, 4, negative 1.45. So the first solution for B, okay, this is for part B, it's going to be negative 1.5. But here the inequality is going to be less than or equals to. Okay, since your inequality has equal to, so the final answer should have none equals to. Okay, and as for these 2 points, okay, estimated, so this one is going to be negative 0.1, 0.2, 0.3, negative 0.4. So this is negative 0.4. And this point, okay, it is between the two boxes, the two small lines. So for this one, okay, let's change the pen a bit. Okay, 1, 2, 3, 4, 5, 6, 0.7891. Okay, so this is between 0.8 and 0.9 positive. So let's say the estimation it's maybe around 0.85. Okay, this is x equals to 0.85. So this one for the inequality, okay, this is between two numbers. So the inequality is going to be negative 0.4 less than or equals to x less than or equals to 0.85. So this is the solution for part B. Hence, of the inequality, the cubic function is below or less than negative 1. So there you have it. So I hope this might find helpful for your filling in notes. So with that, thank you very much and see you next time.